Hey there, fellow mathematicians. Welcome to the next lesson, at home edition. Um, Today we're going to learn how to simplify radicals. That is the second section of chapter 9. For this section, it's important to know what perfect squares are because a simplified radical will have no perfect square factors other than 1. So, for example, the square root of 20 is not simplified because 4, which is a perfect square, divides 20. So it simplifies to um, the square root of 4, which is 2, and the square root of 5, which is not a perfect square, so 2 square roots of 5. So for this section, it's really important to know the perfect squares. So over here on the left margin, we will do, oh, sorry, my dog is wanting to go outside. So over here on the left, we will write down the perfect squares. So in case you don't know, 1 squared, 1. So these over here are my perfect squares. 1 is a perfect square. 2 squared is 4. So 4 is a perfect square. 3 squared is 9. 9 is a perfect square. 4 squared is 16. 16 is a perfect square. 5 squared is 25. 25 is a perfect square. 6 squared is 36. 36 is a perfect square. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. I don't know. Let's go to 15. If you know up to 15, you're doing pretty good. 11 squared is 121. 12 squared is 144. 13 squared is 169. 14 squared is 196. And 15 squared is 225. So if you know all of those, simplifying radicals is very quick work. So again, the numbers on the right are the perfect squares: 1, 4, 9, 16, 25, 36, 39, 64, 81, 100, 121, 144, 169, 196, and 225. Those are all perfect squares, and obviously you can keep going with that list if you want to. But to simplify a radical, all you got to do is just figure out, is there a perfect square that divides it? And if it does, do that division and simplify until there are no more perfect squares that divide it other than 1. So let's look at our first example, 54. So you're going to look at your list of perfect squares, and which of these divides 54? Well, 9 times 6 is 54. So we can say that the square root of 54 is the same as the square root of 9 times the square root of 6. And then, what's the square root of 9? Well, over here, it's 3. Because 3 times 3 is 9. So the square root of 54 simplified is 3 square roots of 6. And that's all you have to do to simplify a square root. Not too difficult. And we'll just do the next ones. Again, ask yourself, what perfect square divides 12? You look at your list, or you think about perfect squares, and 4. So you say the square root of 12 is the square root of 4 times the square root of 3. The square root of 4 is 2. So it's 2 square roots of 3. Number 3. Now there's multiple ways to do this one. 25 divides 200. 100 also divides 200. So it's best to do the biggest one. Otherwise, if you did 25, you just have to do it a couple of times. So I would say that the square root of 200 is 100 times 2. The square root of 100 times the square root of 2. And the square root of 100 is 10, so it's 10 square roots of 2. Remember, once you apply the radical, that number is no longer under the square root symbol. Number 4, the square root of 35. We look at our list. 4 doesn't divide it, 9 doesn't divide it, 16 doesn't divide it, 25 doesn't divide it, and 36 already too big. This one is already simplified. No perfect square divides the square root of 35 other than 1, of course. All right, so number 5 and 6, we add a number in front. It makes it no different. Remember, it just means multiplication. So you simplify. We have 3, or we'll just rewrite. The square root of 8, what perfect square divides it? Well, 4. So the square root of 4 times the square root of 2 is still the square root of 8. And then what's the square root of 4? It's 2. So we have 3 times 2 square roots of 2. We do that simplification right there. 3 times 2 is 6. So we have 6 square roots of 2. And then if you want to pause the video and try 6, you can. Otherwise, I'll just go ahead and do it. Again, what perfect square divides 40? That would be 4 times 10. So the square root of 4 times the square root of 10. The square root of 4 is 2, so we have 5 times 2 square roots of 10. And that would be 10 square roots of 10. No other perfect square divides 10, so that is as simplified as it gets. So there's your product rule for square roots. Next, we're going to be looking at fractions, divisions. So it says that if you have a radical over a fraction, you can separate it into the two separate radicals, one for the numerator and one for the denominator. So we'll look at those examples and simplify these radicals. So first thing we would want to do is rewrite this as the square root of 25 on top and the square root of 36 on bottom. And both of those happen to be perfect squares, so this is nice and easy. The square root of 25 is 5. The square root of 36 is 6. So it simplifies to 5/6. On number 2, again, start by separating the radical into the numerator and the denominator. You look at the numerator, and there's no perfect square that divides 3 since it's a prime number. So it's going to stay the square root of 3 in the numerator. In the denominator, the square root of 64 is 8. Number 3, again, start by separating. We'll have the square root of 40 on top, the square root of 81 on bottom. So on top, this is like one we've seen before. What perfect square divides 40? So we're going to break that into 4 times 10, the square root of 4 times the square root of 10. And the square root of 4 is 2. So it's going to be 2 square roots of 10 for the numerator. The denominator, square root of 81, is a perfect square, is 9. Now, here's what you need to keep in mind. If the 2 and the 9 were both even numbers, let's say, then you would want to reduce that fraction. So if it reduces, you can reduce. You cannot reduce radicals with normal numbers. So it's just got to be the 2 normal numbers. You can't reduce radicals with those numbers. If you want to pause and try 4, go ahead. Otherwise, I will explain it to you. So you should have done the square root of 18 on top, the square root of 25 on bottom. 18 is divisible by, the perfect square is 9, so 9 times 2 is 18. And last thing, we would have the square root of 9 is 3, square roots of 2, and the square root of 25 is 5. Again, the 3 and the 5 don't reduce, so that's going to be our final answer there. So you can see this isn't too difficult of a process. You just got to know your perfect squares. Okay. Now this next section, I guess, not the last section, is, so now we're going to look at what happens. So, yesterday we had only things that were evenly divisible. So, what do you do whenever the square root doesn't go evenly into the exponent? So it's kind of like a division problem, right? Just like yesterday. If we're doing the square root, how many times does 2 go into 5? It goes into it twice with a remainder of 1, right? So that means, so these are going to be, representing my exponents for my answer. So I'm going to have x to the second on the outside of my parenthesis, or not parenthesis, but radical, and x to the first inside of my radical. So however many times it goes into it, that's your number outside of the radical. The remainder would be what's left on the inside. So that's how I would do a problem like that. For a problem like 6, I would probably separate those into the 2 radicals and simplify them individually. So I'd say this is the same as the square root of 8 times the square root of y squared. And we know how to do the square root of 8, and we know how to do the square root of y squared, so we just got to do both of those kind of separately and then put our final answer all together. The square root of 8 is the same as the square root of 4 times the square root of 2. So that would be 2 square roots of 2, right? the square root of y squared is y. And then I just want to have my final answer. I'm going to put my things outside of the radical together, and the things inside of the radical will go together as well. So my final answer would be 2 on the outside, the y on the outside, and the square root of 2 goes last. The radical always goes last on the answer. So it's 2y square roots of 2. Number 7, we would again make the 2 separate radicals, the square root of 45 on top, the square root of x to the 6th on bottom. What perfect square divides 45? Well, 9, right? So that's the square root of 9 times the square root of 5. On bottom, we can just do that. Remember, it's an understood index of 2. We divide 6 divided by 2 gives us x to the 3rd in the denominator. And then we just need to simplify that square root of 9. It is 3 square roots of 5 over x to the 3rd. Okay, and then last one, number 8. Again, I would probably separate as much as I can. So I'm going to do the square root of 5. I'm going to do the square root of p cubed. I'm going to do the square root of 9. Okay, so then let's look at the pieces. Does the square root of 5 simplify? No, it's a prime number, so that's going to stay the square root of 5. For this one, remember your index, your understood index is 2. So as a division, how many times does 2 go into 3? It would be once with a remainder of 1. So if we turn that into radicals, it would be p to the first with the square root of p to the first. And then if we put all of that together, we have the p on the outside, right? That p on the outside. And then we have the square root of 5 and the square root of p still on the inside. And then putting those in the correct order, it would be 5p on the inside. And the denominator, very simple, square root of 9, 3. So you just do it, again, piece by piece, and then put all your pieces back together for your answer. I think that's the best way to do it. Now, the last thing is we're going to be looking at cube roots and some fourth roots. So we'll, like we did on the front, we'll talk about some of the perfect squares and some of the perfect cubes. All right, I guess perfect cubes and perfect fourths. And you don't need to know that many of them. So let's do like 1 cubed, which of course is 1, 2 cubed, which is 8, 3 cubed, which is 27, 4 cubed is 64, and 5 cubed is 125. If you know 1 through 5 for perfect cubes, you'll be doing just fine. And then for perfect fourths and perfect fifths, you don't really need to know many of them. Maybe 1 through 3, or maybe even just 1 to 2. So 1 to the 4th is still 1. 2 to the 4th is 16. 3 to the 4th is 81. And that's probably the only ones that I would know for the fourths. And then for the fifths, I don't know, maybe just 1 and 2. 1 to the 5th is 1. 2 to the 5th is 32. If you want to do 3 to the 5th is 243. Gets very big very fast. So that would be enough to know the cubes and the fourths and the fifths. So we're going to use that information to help us with simplifying these cube roots on top and these fourth and that fifth root on bottom. So let's look. Cube root of 54. So we're not looking for perfect squares that divide 54. We're looking for perfect cubes that divide 54. So which of these divides 54? Well, 27 does. So we separate this into the cube root of 27, and the cube root of 27 times 2 is 54. And what's the cube root of 27? It's 3. And it comes out of the radical because we've applied the root. And then we would have the cube root of 2 left over. So it's 3 cube roots of 2. Similarly for number 2, what perfect cube divides 18? 1 does, but it doesn't change anything. 8 doesn't divide it, and 27 is already too big. So this one is actually already simplified. Number 3, we've got the quotient, so we're going to separate it into the cube root of 7 and the cube root of 8. So on top, cube root of 7, obviously none of those perfect cubes divide it, so it's going to stay that. What's the cube root of 8? It's 2. So this is the cube root of 7 over 2. And then number 4 there, the cube root of 40 over the cube root of 27. What perfect cube divides 40? Again, 8. So we're going to say that's the same as 8 times 5, both in cube roots. On bottom, the cube root of 27 is, of course, 3. And then just apply that last one. Cube root of 8 is 2. So it's going to be 2 cube roots of 5 over 3. Okay. All right, number 5 there, our first fourth root. So 16 doesn't divide 243 because it's odd. 81 does because I know that 3 to the 5th is 243. So if you know that, that is really helpful for this. So this one is 81 times 3. The fourth root of 81 times the fourth root of 3. And what is the fourth root of 81? It's 3. So it's 3 fourth roots of 3. Interesting. And then the last two, pretty apparent because it's the fourth root of 16, which is that. So it's the fourth root of 3 over the fourth root of 16. Fourth root of 16 is, of course, 2. So it's the fourth root of 3 over 2. And this one, 64, obviously divisible by 32. So 32 times 2 is 64. And the fifth root of 32 is 2. So we have 2 fifth roots of 2 for that one. So again, not too difficult. If you have any questions, reach out. I'm available. It's a great day to be a mathematician. Good luck, guys. Have fun.